evening all. We will see today differentiability. Last class we have completed the continuity and also problems also we have completed. Today we will see differentiability. Before entering into the differentiability concept, we have to see what is derivative. Clear? So if I am taking a function y equals to f of x, so the graph of the function, it is given like that. It is my graph of function f of x. I am going to take 2 points on the graph. This is p, this will be q. Suppose I am going to take the coordinates of the p. So if I am joining here means the distance from the origin equal to a units. Distance from the origin equal to a units from the y axis. So distance of the point from is a unit from the y axis. So this point will be a. And what about the second coordinate, y coordinate? If a am taking the point equal to a means the corresponding value of the function is substituting here, that is f of a. So this point will be a comma f of a. If I am taking a point q, I have taken the point q, I am assuming that the q point is h distance from the point a. That is h distance from the point a. So we are taking this point will be, if it is already a, this distance equal to h, so this will be a plus h. Clear? If it is a plus h means our coordinate will be f of a plus h. F of a plus h. Now what I am going to do, I am going to join a line PQ. After joining the line, I am going to find the slope of PQ. What is the slope of straight line? Slope of straight line already we have studied. That is slope of the straight line equal to y2 minus y1 divided by x2 minus x1. So I am taking, this is my coordinate x1, y1. This is my coordinate x2, y2 means our slope of the straight line PQ equal to f of a plus h minus f of a divided by x2 coordinate is a plus h minus x1 coordinate is a. So this minus a and plus a will get cancelled. Our slope will be f of a plus h minus f of a divided by h will come. It is the slope of the straight line PQ. Now what I am going to do, I am going to take the point q here. For example, it is q dash or q1 I am taking. In this case, what is the coordinate of q dash? Suppose the q dash is the distance here. The distance that is the coordinate of q dash is, if it is h1 means clearly h1 is less than h. So this coordinate of q dash will be a plus h1 and f of a plus h1. Clear? The coordinate of q is a plus h1 comma f of a plus h1. In this case, I will get the new slope. That slope is f of a plus h1 minus f of a divided by h1 will come after simplifying. This is the slope of the pq dash. Clear? Suppose similarly I am taking a point q. The point q is traveling along the path of f of x. Traveling along the path of f of x, and the q coordinate is very near to p. Very near to p but not equal to p. In that case, what is happening? For suppose example, I am taking a point here, that is q2 I am taking here means the distance between the p and q2 will be h2, that is very much less than the value of h. Similarly, I am taking the point qn, that is very close to p. Qn I am taking very close to p, that Qn is, for example, Hn, that is very much less than the value of h. Clear? That is Hn I am taking, that is very much less than the value of h. So what is happening here? The distance between the coordinate p and q is minimizing. Actually, first is somewhat, for example, 8 units, second case 7 units, 6 units, 3 units, 0.5 units, 0.01 units, like that. The distance between the coordinates P and Q are reducing, distance between the coordinate is reducing but not equal to 0, but you are observing that the coordinate, the distance between them is tending to some point, that is the closing to 0. So for that case we have to introduce the limit. So I'm introducing a limit here. Limit h tends to 0, that is the coordinate distance between the coordinate P and Q is tending to 0, that is h tends to 0, f of a plus h minus f of a divided by h, which is called the derivative of the function, at the point x equal to a. So I am taking this is called f dash of a. Clear? So this is called our f dash of a. As we discussed in the last continuity topic, we have taken left hand limit and right hand limit we have found, we equated with that. Similarly here also a function is differentiable. A function is differential means we have to prove that left hand derivative is equals to right hand derivative. We have separate definitions for left hand derivative and right hand derivative that we will see now. After that we will move to the some formulas. We have some formulas, theorems, chain rules we will see. Then we will move to the exercise problem 5.2. It is very important definition, LHD, that is left hand derivative. LHD equal to, for example, I am going to find the derivative at the point x equal to a, derivative of f of x at the point x equal to a, that is left hand derivative f dash of a equals to limit h tends to 0 f of a minus h minus f of a divided by minus h. This is my left hand derivative. What is right hand derivative? RHD. RHD at the point x equals to a means f dash of a is equals to limit h tends to 0 f of a plus h minus f of a divided by h. This is my right hand derivative and left hand derivative. So some rules we will see. For example, if two functions, already we have seen the many formulas of differentiation in the plus one, so many trigonometric ratios, some algebraic functions we have studied, some polynomials we have studied, some functions we have studied the derivatives, we have found the derivatives. This class we are going to use the derivatives in the functions. We are going to differentiate the functions with respect to x and with respect to y also. With respect to one variable we are going to differentiate another variable or another function. So now before entering into that we have to see some formulas. So what are the formulas means? First one is u plus v the whole dash or u minus v the whole dash. Here the dash refers, for example, f dash means first derivative. F dash means first derivative of f. For example, f dash equals derivative of f double dash we will study later. So dash refers the derivative, or sometimes we will see d by dx, or sometimes we will see y1. All these things referring the first derivative of the function. So u plus v whole dash means differentiation of sum of two functions equals to differentiation of first function plus or minus differentiation of second function. This is our first rule. Second rule is, if two functions are in multiplication, two functions are multiplied each other means, and finding the derivative, that is equal to derivative of the first function into second function plus derivative of the second function into first function, or you can write u v dash or v dash u. This is called product rule. This is called product rule. One more name is there, that is called Leibniz rule. Leibniz, Leibniz rule or product rule we will say. And finally one more rule is there. The two functions are in division, that is numerator is one function, denominator is one function means, then finding derivative which is equal to u dash v minus u v dash divided by v square. Here v, the function denominator function, should be not equal to 0. Clear? These are the three important rules. In these three important rules, second and third are very important. Second and third are very important rules. Clear? So next we will find the we will chain rule. After that we will move to the exercise problems. So before entering into the chain rule, we have to know one definition. So what is the definition means? A function is differentiable at the point C, then it is also continuous. For example, if I am saying if f is differentiable, if f is differentiable at C means, then it is obviously also continuous. It is also continuous at the point C. Clear? A function is differentiable at C means it is continuous at C. But what about the inverse? Inverse means it is continuous if f is continuous. If f is continuous at C, then f need not to be if f need not to be differentiable, which means every differentiable function is continuous, but every continuous function need not to be differentiable at the point C. For example, we can give modulus function. Modulus of x is continuous function. Modulus of x is continuous, but modulus of x is not differentiable. Continuous at x equal to 0, it is continuous. Everywhere it is continuous. Particularly x equal to 0, it is continuous. But modulus of x is not differentiable at x equal to 0. So from that we can clearly say every differentiable function is continuous, but every continuous function need not to be differentiable. Sometimes it is differentiable, sometimes may not be differentiable. Sometimes means some functions. Some continuous functions are differentiable, but all the continuous functions is not differentiable. Example I have given, it is modulus of x. Clear? So from that we can derive that every differentiable function is continuous. Clear? We will study the chain rule now. So what is the chain rule means? F be a real valued function. So we will study the chain rule, which is important rule to differentiate the functions. Chain rule, let f be a real valued function. So what is real valued function? Real valued function means whose range must be a real number or subset of real number. Okay, real valued function, and which is composite of two functions, u and v, which means f is a composite of two functions, f equal to u composition v given. Clear? That is f equal to u composition v. Yesterday class we have studied u composition v. What is u composition v? That is u of v of x, or u of v of f of x equal to u of v of x, like that we can take. So f is the composition of two functions u and v, and suppose t equal to u of x, and if both dt by dx and dv by dt exist. Dt by dx and dv by dt exist means we have df by dx can be written as dv by dt into dt by dx. This is our chain rule. Okay, the same chain rule we can it is applicable for the composition of three functions. For example, f is a composition of three functions, that is u w. For example, u v w, we can take w composition u and composition v means what is the value of df by dx in this case? It is f is a composition of three functions w, u and v, so that we can write as dw by ds, then ds by dt, then finally dt by dx. Clear? This is the chain rule. While solving problem we can understand easily the chain rule. Now we will move to the exercise problem 5.2. Differentiate the functions with respect to x in the exercise 1 to 8. So before entering into the exercise problem, we have to recall some formulas. Differentiation of sin x equal to cos x, differentiation of cos x equal to minus sin x. These like that formulas we have to recall, and then only we have to solve the problems. Okay, so now come to the exercise problem. Exercise first question. So what is given? For example, I am taking f of x equals to sin of x square plus 5. I am going to differentiate this function. We are going to apply the chain rule now. So to find the differentiation f dash of x or dy by dx, whatever it is, we can take. So now differentiate the sine function, whatever may be in the value or in the x, don't consider, no problem. Whatever may be in the x place, first differentiate the sine function. Differentiation of sin x equal to cos x, so cos of x square plus 5. Then what we have to do? We have to differentiate what is in the place of x, that we have to differentiate and we have to multiply with that. So now differentiating and multiplying, what will come? We will get cos of x square plus 5, differentiation of x square equal to 2x, differentiation of constant equal to 0. All these things we have studied. If you didn't study means we just recall. What is that? D by dx of sin x equal to cos x, that I used here. Similarly, d by dx of x power n equal to n into x power n minus 1, that formula also used here. I used here d by dx of constant c, that is equal to 0, that also I have used here. Now we can simplify and write 2x into cos of x square plus 5 is the derivative of the given function. What is the question number 2? Question number 2, we can take, this time we can take it as y. So y equal to cos of sin x. As I said already, whatever may be in the place of x, don't consider, no problem. So what is y dash or dy by dx? We can write dy by dx or y dash or y1, whatever, all the values are equal. So differentiation of cos x equal to, we have to use the formula d by dx of cos x. What d by dx of cos x? That is minus sin x, that I am going to use here. So d by dx of cos of sin x equal to minus of sin of sin x. Next, what I need to do? What is in the place of x, that we have to differentiate and multiply. So differentiation, that is d by dx of sin x. So what is d by dx of sin x? That is cos x will come. D by dx of sin x equal to cos x, that cos x I am multiplying before. So minus of cos x into sin of sin x. It is the derivative of the given function. Clear? Next question. Question number 3. So what is given here? Sin of ax plus b. Question number 3, we can take it as y equal to sin of ax plus b. So same, we have to consider whatever in the place of x, consider as x. So derivative of the sin function, d by dx of sin x equal to cos x. So this will be cos of ax plus b. Again I need to apply the chain rule, that is what is in the place of x, that I am going to differentiate and multiply with that. So d by dx of ax plus b equals to, what will come? Differentiation of ax means a into 1, differentiation of b, that is constant, that is 0 will come. So cos of ax plus b, differentiation of this one, a plus 0 will come. That constant will be multiplied before, a into cos of ax plus b is the answer. Clear? Now question number 4. So what is question number 4 given? Y is equals to secant of tan of root x, secant of tan of root x. So up to question number 3, the function, given function is composition of two functions. So this question, fourth one, it is a composition of three functions. What are the functions? Secant function, tan function, root x function. Clear? So we have to see two or three more formulas. What is that? D by dx of secant x. D by dx of secant x, that is equals to secant x tan x. Clear? Next, what is the value of differentiation of tan x? D by dx of tan x. D by dx of tan x equals to secant square x. Clear? One more thing, we have to know the differentiation of root x. So how to differentiate root x, sir? D by dx of root x, this can be written as d by dx of x power 1 by 2. So how to differentiate x power 1 by 2? We have to use this formula, x power n equal to n into x power n minus 1. So I am differentiating means 1 by 2 x power 1 by 2 minus 1, that is nothing but 1 divided by 2 into x power half will come, so that is x power minus half will come, writing in denominator x power plus half. So 1 divided by 2 times root x. So d by dx of root x equal to 1 divided by 2 root x. This also we are using this many times, we will use this many times, so we are writing this also one of the formula or one of the result. D by dx of root x equal to, we will write it as 1 by 2 root x. Clear? These three I am going to use in this problem. Now what is derivative? First, y dash equal to secant into whatever may be in the place of x, consider as it is x. So differentiation of secant x equal to secant x tan x. So I am writing this as secant of tan of root x into tan of root x into what will come? D by dx of d by dx of what is in the place of x, that is tan of root x. Tan of root x. Clear? Now this I am going to differentiate this. So first will be as it is secant of tan of root x into tan of tan root x. Tan of tan root x, tan of tan root x into d by dx of tan root x, that is whatever may be in the place of x, we have to consider as x alone. Differentiation of tan x equal to secant square x. So what will come? We will get secant square root x. Finally what we have to multiply? We have to multiply d by dx of root x. Clear? So first time I applied secant of tan x means I differentiated secant x, that is secant x tan x. So secant of tan root x into tan of tan root x. Then I am differentiating in the place of x, that is tan of root x. Here also composition of two functions. Differentiation of tan x equal to secant square x. So secant square root x will come. Again d by dx of x in the place what is available? Root x available. Now we will apply the d by dx of root x. D by dx of root x equal to 1 by 2 root x. So finally I am writing y dash equal to secant of tan of root x into tan of tan root x into secant square x. I don't have place, I am erasing and writing here, that is d by dx of root x. So remaining, that is secant square root x. Differentiation of root x equal to 1 by 2 root x. So that is I am writing denominator 2 into root x. This is the differentiation of the given question or derivative of the given question. Clear? So remaining problems from problem number 5 onwards we will see in next class. Most probably we will complete the 5.2 in next class. Thank you.